A series is just the sum of a sequence. So we can find the sum of a sequence if we can add it in some fashion. So we might be able to put the sides together if we're looking at shapes. For example, if we're looking at, if we have, say, this shape and then this guy and this guy, maybe that guy there, if we put those all together, we get something like a box. Granted, I didn't draw them in the order, but we could conceivably add those together and make a box of some sort. Or maybe it would look more like that. But there's some way that we can put them together. So when we're dealing with numbers, it's sensible to just be able to add them. Now, if our sequence is finite, there's going to be a sum because there's a place where we get to stop. If our sequence is infinite, it might have a sum. It'll depend on the situation. Now, the examples that I'm going to do in here are just going to be small finite series that we're going to be looking at. We'll deal with infinite sequences in series at another time. So our general notation, instead of writing out, okay, I want 2 plus 4 plus 8 plus 16 plus 32, and then on for however long I want to go, it's going to be much easier to write it using what's called summation notation. And we use the Greek letter sigma, capital sigma, and then we say, okay, we're going from our kth term to our nth term. So we're going to start at k equals 1, and we're going to go up to whatever our stopping point is. In this case, so we have our a term, a sub k term. So a sub 1 plus a sub 2 plus all the way up to a sub n. So we're replacing that k by our numbers that we have in our summation notation. So in this case, if I wanted a sub 1 to a sub 5, we would write the summation of k equals 1 through 5 of a sub k. So in this case, we would just put that in. So what is a sub k in this case? Well, if we remember, this is our geometric sequence with our ratio of 2, and it's going to our k power. So we can just add those. But I have a couple of examples that we can work with. So let's take a look at those examples. So like I said, a sub k, this notation just means a sub 1 plus a sub 2 plus a sub 3 all the way up to a sub n. So for this first example, k equals 1 up to 5. So I replace the k by 1. And then I say, okay, summation means I'm going to add. Sum means add. And then I say, okay, we're going to replace k with 2. We're going to replace k with 3. We keep going until we reach 5. And so we're just going to add those numbers together. So 1 plus 2 is 3, and 3 is 6, and 4 is 10, so this is 15. So that's all there is to that nice little example. Now here we have a little bit more going on, but again, we kept it short. We're only going up to the 5th term. So this is 3 times 1 plus 2 plus 3 times 2 plus 2 plus 3 times 3 plus 2 plus 3 times 4 plus 2 plus 3 times 5 plus 2. And we can stop because our k has hit 5. So k equals 1 through 5, and we're done. But we still need to do that arithmetic. So let me change my color here. So we have 3 times 1 plus 2, and that's 5, plus 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11. 3 times 4 is 12, and 2 is 14. 3 times 5 is 15, plus 2 is 17. So we still have a little bit more to do. We still have to add these guys together. So this is 13 and 11. So 13 and 11 is 24 plus 14 plus 17 gives us a total of 55. So you should have 55 here for the series given by this formula. Now we can also have other things happening. So here we have a geometric series. In fact, this was in our geometric sequence example, but we're only looking at the first 5 terms. So again, it's 3 times 2 to the first plus 3 times 2 to the second plus 3 times 2 to the third plus 3 times 2 to the fourth plus 3 times 2 to the fifth. So we're going to put an extra step in here, so it's 3 times 2 plus 3 times 4 plus 3 times 8 plus 3 times 16 plus 3 times 32. So now we just need to add these guys together after we finish the multiplication. So it's 6 plus 12 plus 24 plus 48 plus 96. And then we can just add these terms together. And you should have 186. So I hope this helps you with the basics of a series and working with the summation notation.